All right, so we left off yesterday with example 3. We had just done this problem, which was about finding the trig functions on the unit circle. So now, what I want to do is look at the information we have, and I want to figure out the angle. Okay, any one of these 6 pieces of information is enough to figure out the angle. But what we're going to do is we're going to use the sine. Okay, there's a reason why I want to use the sine, and we'll talk about that a little bit more on the next page. So let's write down what we have. Sine theta equals, and it really doesn't matter whether you have the root in the bottom or you don't, because now we're solving for theta. Okay, so it doesn't matter. You need to have the correct thing on the right hand side, any format you want. I'm gonna use the one on the left because that's less for me to type in on the calculator. So sine theta equals 3 over root 13. Okay, to solve for that angle, I have to get rid of sine. And what do we use to get rid of sine? Yeah, inverse sine. And how do you explain what to do with inverse sine on both sides? Yeah. Yes, you take. We don't say multiply. There's no multiplication happening there. Okay, we're going to take the inverse sine of what's on the left. And then we're going to take the inverse sine of what's on the right. So when you say take, it means you're taking what's there. It's becoming an argument. And it's being plugged into another function. Okay. What happens with inverse sine and regular sine? Yeah, they cancel out. So I'm left with theta, and this is going to be approximate. Okay, it's not going to be an exact answer. So second inverse sine. 3 divided by square root 13. Okay, it's about 56.31 degrees. Now, this is a problem where I wouldn't ask you for an exact answer because you can't do it. Okay, the answer doesn't come out nice in degrees. It doesn't come out nice in radians. Any question how we figured out the angle from example 3? And think about 2, 3. What quadrant is that point in? It's in quadrant 1. So the angle that you get should be a quadrant 1 angle. Quadrant 1 angles are between 0 and 90, and 56.31, that it's in quadrant 1. Okay, so that's an acute angle, right? It's between 0 and 90. Now, if we had to find an angle that was in a different quadrant, okay, we've got to be a little bit careful because it's not going to be an acute angle. Okay? It's going to be an angle that's bigger than 90 if it's in another quadrant. Okay, so how do we find the angle if I give you a point not in quadrant 1? I'm going to show you what you do. First thing we need to do is pretty much what we already did. We're going to find the absolute value of the inverse sine. And if your point was in quadrant 1, you'd be done now. That's all you have to do. Inverse sine. If you're not in quadrant 1, we're then going to do something with that. And let me show you why you have to do something with it. Let's put this point in the third quadrant. Let's make it -2, -3. Let's see what happens. Okay, so let's get a grid up here. Let's use this one. All right, so I've got the point -2, -3. -2, -3. So I'm trying to find the angle that has terminal side right there, and an initial side right there. That's the angle that I want to know. Okay, is that angle bigger than 90?
Yes.
Yeah. Well, when you do inverse sine, we're going to learn more about it. Inverse sine is never going to give you an answer bigger than 90. Okay? So let's see what we can do. So it says, first find the absolute value of the inverse sine. So let's look at our problem. Oops. Here's our point. I'm going to draw a picture and kind of give you a hint of what we're going to do. Yeah?
You could just add the answer we got before to 180.
Right. It's exactly what we're going to do. When you're in quadrant 3, you do a plus 180. There's a pattern for each quadrant. So essentially what we're going to find is this. That angle that we're going to find, it's exactly the same angle we found in quadrant 1. What was it, 56 something? 56.31. Okay. So when you do that inverse sine, remember sine is y over r, so it's -3 over square root 13. Okay. Type that in. Inverse sine -3 divided by square root 13. And then take the absolute value of 56.31. That's called a reference angle. This angle right here. It's 56.31. So Rich, what did you say to do to get this whole thing?
Just add 180.
Yeah, take 180 and then add your reference angle. Now, what if you were in quadrant 2? Let me erase this and just draw a triangle in quadrant 2. Same triangle. But let's say this time I want to know this angle. Your reference angle is going to be right here. Yeah.
You would have to figure out what you figure out what the angle is right there without the you'd have to add 90 degrees to whatever angle is right there.
Well, we're going to find this angle right here.
Wait, you'd have to subtract that angle from 180.
Yeah. So in quadrant 2, to find the full angle, you find your reference angle, which is the inverse sine, and then you subtract that from 180. Okay? In quadrant 3, you find your reference angle, and you add it to 180. Now, how about quadrant 4? So let's say you had a triangle here. And now you want to find that angle, and you're going to know that angle. Your reference angle is always between the x-axis and the hypotenuse. So if we knew this, what do you think you would do? Yeah?
You add it to 360 or subtract it?
Subtract it from 360. Yep. So like if this was 10, then all the way around would be 360 minus 10, or 350. Okay? So let's write that down, what we do in each quadrant. Okay, so quadrant 2, I put 180, but what would that be if you were doing it in radians? Yeah? Pi. Okay, so 180 minus the reference angle. To find it in quadrant 3, it's 180 plus the reference angle. And to find an answer in quadrant 4, it's 360 minus the reference angle. I'm going to show you a problem in a second that uses exactly what we have up there. Okay, so any questions on the patterns to find the angle in a quadrant using what we call the reference angle? Okay, so let's look at so we kind of already we already did -2, -3. All right, let's just try 2, -3. So right 2, down 3. It's just a reflection of the triangle we already did in quadrant 1. So we should already know what this reference angle is right here. The angle between the x-axis and the hypotenuse. What is that reference angle? Yeah?
56.31 or
I think it was 3.1. Yeah. So it says the point 2, -3 is on the terminal side. There's my terminal side. There's my initial side. Now the question is to find that. So what are we going to do with the 56.31? Yep.
We'd subtract that from 360.
Yep.
It's basically the same between numbers 2 and 4. It's just the 180 is now 360.
Yep. So if you had to find the angle created when the terminal side is on 2, -3, it's 303.69 degrees. Okay. Any question on that? Okay. What's the other thing I want? Okay. So that works fine as long as you have a point that doesn't have a 0 in it. Okay. If your point has a 0 in it, where are you going to end up? Yeah? You're going to end up on one of the axes. So when you land on an axis, we really just have to memorize what those angles are. Because if you try to draw the triangle, you can't. If you're on an axis, there's no, the hypotenuse is the leg of the triangle. There's no reference angle we can really do. So if you end up on one of the axes, we have to remember that the angle is either 0, 90, 180, or 270. Okay? Okay, so for the quadrantal angles, the angle is either 0, 90, 180, or 270. And all the trig functions come out to either 1, -1, 0, or undefined. Okay, you don't get decimals, you don't get square roots, you don't get fractions. All trig functions come out to 1, -1, 0, or undefined. Undefined happens when you have a 0 in the bottom of the denominator. So what's our formula that we talked about for sine yesterday? Yeah?
The 2 pi over b1?
No, not the period. Just the formula to calculate sine. Yeah.
Just like opposite hypotenuse.
Yeah, it's like opposite over hypotenuse. Well, when you're calculating sine, the hypotenuse would never be 0. So you never have to worry about undefined with sine. You never have to worry about undefined with cosine either. The only functions that can have an undefined are the tangent and the cotangent. They have vertical asymptotes. And the secant and the cosecant. And sine and cosine are never undefined. All right, so yeah, last thing. Let's say I had something like this. All right, kind of did something like this before. I just want you to find the angle. How do you get rid of sine so we get theta by itself? Yeah? Okay, take the inverse sine on both sides. And take the inverse sine on the right. And what happens with inverse sine and regular sine? Yep, they cancel out. So we're left with theta equals inverse sine of 1/3. Okay, let's see what that comes out to. Second inverse sine of 1/3. It's about 19.47 degrees. Okay, so that's solving it algebraically. How can I solve it graphically? Sine theta equals 1/3. What could I put in y1? Yeah? Yep, so we could put sine of x in y1. What would go in y2? 1/3. And before we graph it, what should we always do? Yep, you gotta set the window. And you always want to set your window so that it is one cycle. We don't want to look at more than one cycle. So this is the sine function. What's the cycle for sine? In degrees. Yep.
360.
Yep. So let's set our window to go from 0 to 360. So we're going to see one full cycle. How high and low does sine go?
1 to -1.
1 to -1. So let's just do -2 to 2. Okay, let's hit graph and see what happens. Okay, so we're going to get one cycle of sine. And before I even show you the rest of the graph, how many answers did we get when we just did what we did algebraically? We got one answer. Okay. Does anybody see more than one answer on the board right now?
No.
How many answers do you get there?
2.
2. There are 2 answers there. So what happened? How did we lose one? Well, let's calculate the intersect. Second calc intersect. Let's do the one on the left. What do you think the one on the left is going to come out to? 19.47. Yeah. So we got the answer on the left. The problem is the calculator won't give you the second answer. But you can find the second answer using something I just showed you and one other thing I'm going to show you. Yeah.
The length of the period thing?
Well, the second answer has more to do with this. Okay. What we just found was a reference angle. To find the second answer, we have to use one of these. The trick is, how do we know which one to use? Should we take and subtract it from 180? Should we add it to 180? Should we subtract it from 360? It's one of those 3 things to get this answer over here. Yeah?
I'm pretty sure we have to subtract it from 180 because it's right behind the 180 point. It's not past the 180 point. The 180 point would be at 0.
Yeah, we are going to subtract it from 180. I want you to be able to figure that out without seeing this picture. Okay, how do you know you should take whatever we got, 19.47, and how do you know to subtract that from 180 to get this answer? Well, that's where this chart comes in handy. Once I explain it, it's a pretty simple chart. This chart tells you where the different trig functions come out positive. In quadrant 1, if you take the sine, the cosine, or the tangent of any angle between 0 and 90, all of them will come out positive. If you give me an angle between 90 and 180, and I plug it into sine, it will come out positive. If I plug it into cosine or tangent, it will come out negative. If you give me an angle between 180 and 270, the only trig function that comes out positive with those kinds of angles is tangent. If you give me an angle between 270 and 360, the only trig function that comes out positive with those angles is cosine. So ASTC tells you which trig functions are positive where. So let me show you how you use that to figure out the question I just asked you. There it is. Okay, look at the original problem. It says sine of theta equals what kind of number? Is it equal to a positive number or a negative number? Yeah? It's equal to a positive. We're looking for where the sine comes out to a positive. So that tells you the two quadrants. Sine will be positive here, and sine will be positive there. When we did inverse trig, which answer did we get? Quadrant 1 or quadrant 2? Yeah. We got the quadrant 1 answer. Now we need to get an answer in quadrant 2. We know that from the chart. Now, when you're in quadrant 2, what's the formula that I showed you earlier? Yeah.
180 minus theta.
180
Or minus theta.
minus your reference angle. So the reference angle is 19.47. So take and subtract that from 180. So the other answer should be 160.53. Let's check the intersect and see if that works. Second, calc, intersect. Okay, move your cursor. And look at the other answer that you get, 160.53. All right, so now you know how to figure out both answers without graphing it. Look at your problem, figure out what trig function it is, and then figure out if it's supposed to be positive or negative. Every trig function will be positive in 2 spots and negative in 2 spots. Once you know those 2 quadrants, then just reference this page, and it tells you the formula for that quadrant. Any question on it? All right. So how about this one? Let's do cosecant of theta equals 3. And I'd want you to solve for both answers. What should we try to do to get theta by itself here? Yeah?
Just take the sine.
Well, we got to cancel this out. So how do you cancel out cosecant? The inverse of what? The inverse of cosecant. Yeah. Well, that'd be great if we had a button for it. But you don't have an inverse cosecant button on the calculator. So you can't take the inverse cosecant of both sides. What else could you do? Yeah?
Can't you take 1 over the inverse
Not quite. It doesn't, I know what you're thinking. It doesn't quite work that way, but that's kind of the idea of what we have to do. If the cosecant is 3, what else does that mean? This tells you something else. Yeah?
sine will be 1/3.
It tells you that the sine is 1/3. It's the same problem we just did. If the secant is 3, cosecant is 3, then that means the sine would be 1/3. That's how you have to figure out a problem like that. You have to change to the trig function you have a button for, and then you could do exactly what we did right there. Yeah.
Technically, cosecant is 1 over cosine.
Cosecant is 1 over sine.
That's what I meant, 1 over sine. So, couldn't you multiply, like, both sides by sine? Like,
No, no. You can't multiply by a word.
That's
Yeah. Yeah, can't multiply by a word. You can multiply by letters, numbers, but you can't multiply by a function.
Yeah.
Yeah. Okay. Is there any question on that idea? Be the same thing if you had inverse cotangent. You can't do that. Or inverse secant. You can't do that. But you don't need to. If you know the cotangent, just flip it. Now you got the tangent. And then you have a button for inverse tangent. Okay. So that was really the last thing in that section. So the homework, we pretty much already did that. So for tonight, it'll be so that's the homework. There's a review. It's on Schoology. If you go to the homework and videos, it's right after 6.5 part 2. Okay, so you've got about 35 minutes, so you can start working on it now. At least make sure you know where to find it, so that way you have it. If you want it printed, let me know. You can print it out. Otherwise, you just use blank paper and just do it on there. Okay.
Same here, like one from